Hello everyone, welcome to video lectures and ISR initiative by SSMRV College. SSMRV College, one of the premier institutions run by the prestigious RV group of institutions, has come up with a unique initiative to engage students at the time of this unforeseen medical emergency caused by corona outbreak. As a socially responsible institution, we would like to connect academically with students to make good the losses caused. In this connection, I, Neetha SS of Department of Computer Applications, has posted a video on the subject DBMS and the topic Schedules and Recoverability, Serialization. Please watch the video till the end and like, share with your peer groups and subscribe to our YouTube channel. Thank you. So last class we have discussed about concurrent transactions in DBMS, why concurrent transaction is needed, why recovery is needed. We have discussed. So in this video lecture we'll discuss about serializability, schedules and recoverability. So what is schedules and recoverability? When transactions are executing concurrently in an interleaved fashion, then the order of execution of operations from all the various transactions is known as schedule. A schedule S of n transactions T1, T2 to Tn is an ordering of the operations of the transactions. Operations from different transactions can be interleaved in the schedule S. However, for each transaction Ti that participates in the schedule S, the operations of Ti in S must appear in the same order in which they occur in transaction Ti. Okay, so whenever we are executing the transactions simultaneously in an interleaved fashion, that means in an equal fashion, then the order of execution of operation we call it as the schedule. So schedule we are defining it as S of number of transactions, that is n. Transactions we are defining it as T1, T2 to Tn. It's an ordering of the operations what we are doing in the transactions. Okay, so different operations can be executed in different transactions in the schedule. For each transaction, it has to participate in the schedule. The operation of Ti in S must appear in the same order what it has occurred in the transaction. Example of schedule. Take this as an example, transaction T1. In the transaction T1, we have R1 of X, that means read X. W1 of X, that is write X. Read Y, write Y. C1 means commit. Once you have done read write, you have to commit the transaction. Similarly, take an example of other transaction T2. There also we are doing reading, writing and committing. So overall, how we can schedule this transaction? R1 of X, R2 of X, W1 of X, R1 of Y, W2 of X, W1 of Y, and finally we'll be having C1 and C2. Two operations in a schedule are said to be conflict. So what is conflict in DBMS? Conflict in DBMS can be defined as two or more different transactions accessing the same variable and at least one of them is a write operation. Okay, so if two or more different transaction is trying to access the same variable, in that at least one of them is a write operation. We call it as a conflict. So three conditions it should satisfy. They belong to different transaction. They access the same item. At least one of the operation is a write item of X. So you can see this example. We have schedule S, R1 of X, R2 of X, W1 of X, R1 of Y. So whichever I have indicated in the arrow mark, so it has write operation in it. Then that operation we call it as the conflict in DBMS. A schedule S of n transactions from T1, T2 to Tn is said to be complete schedule if the following conditions hold. Okay, so what is a complete schedule? When multiple transactions are running concurrently, then there needs to be a sequence in which the operations are performed. So because at a time only one operation can be performed on the database, the sequence of operation we know it as a schedule. Okay, so here following conditions it should hold good. The operations in S are exactly those operations in the transaction, including commit or abort operations as the last operation for each transaction in the schedule. For any pair of operations from the same transaction Ti, their order of appearance in S is the same as their order of appearance in Ti. For any two conflicting operations, one of the two must occur before the other in the schedule. So, what do you mean by schedule? Only one operation can be performed in the database. This sequence of operation we call it as the schedule. We have partially ordering of operations in a transaction. What is partial order? When two non-conflicting operations to occur in the schedule without defining which occurs first, thus leading to the definition of a schedule partial order of the operations in the n transactions. We also have committed projection. That means transactions are submitted continuously to the system. So it is difficult to encounter a complete schedule. So that includes only the operations of the committed transactions. We call it as committed projection. Next we have schedules classified on recoverability. Schedules can be classified based on recoverability. One is recoverable schedule and second one we have cascadeless schedule. Okay, so what is schedules? Schedules in which transactions commit only after all transactions whose changes they read commit are called recoverable schedules. Okay, I'll explain it once again. What is recoverable schedule? Schedules in which transactions commit only after all transactions whose changes they read commit are called recoverable schedules, where no transactions needs to be rolled back. A schedule S is recoverable if no transaction in S commits until all transactions that have written some item that has to be read and it has to be committed. We call it as recoverable schedule. In the recoverable schedules, no transaction needs to be rolled back. In schedules, transactions will commit only after all transactions where changes has been made. Cascadeless. What is cascadeless? Where every transaction reads only the items that are written by committed transactions. We call it as cascadeless schedules. Schedules requiring cascaded rollback. A schedule in which uncommitted transactions that read an item from a failed transaction must be rolled back. When we need cascaded rollback, whenever a schedule which is reading an item from a failed transaction that is uncommitted, we call it as cascaded rollback. We need rollback when we are reading the data from the failed transaction. What is strict schedules? A schedule in which transaction can neither read or write an item X until the last transaction that wrote X has committed. So next we'll discuss about serializability of schedules. Based on serializability, the schedules can be classified as serial schedule, non-serial schedule, serializable schedule, that is classified into conflict serializable schedule, view serializable schedule. Okay, so what is serial schedule? Formally, a schedule S is serial if every transaction T participating in the schedule, all the operations of T are executed consecutively in the schedule. We call it as serial schedule. Okay, otherwise it will become non-serial schedule. Okay, so that's what I said. Serial schedule means a schedule S is serial because operations of each transactions are executed consecutively without any interruption in the operation from the other transaction. We call it as the serial schedule. So entire transactions are performed in serial order. That is, transaction T1 is first executed, then followed by transaction T2. So see this example. Here we have two transactions T1, T2. Okay. So what operations we have under T1? We have read and write operation. So which is reading an item of X. Okay. After reading the item, we are subtracting some value from the X. You can assign any values. X as 90, N as 2. You can assume that values. Subtract that. 90 minus 2 will get 88. Then we are updating that value in the database. That is, we are doing write operation, write item of X. Then again we are taking another database, that is read item of Y. We are adding some data to the Y. Y is a person, you can consider that X and Y. Then again you are updating that the operations in write item of Y. So once this operation completes, in the other side transaction T2, we are reading item X and we are adding some other values. That means take up multiple persons are doing different transactions in the database. Take an ATM as an example here. Every day we'll be doing transaction in the ATM, will be withdrawing, will be adding some money into the some other's account. So simultaneously it has to be updated one after the other. We call it as the serial schedule. So the gap we have given here, once this side T1 transaction is completed, T2 is doing. Okay, in the second schedule, that is schedule B, T2 is doing the operation. Once T2 completes, T1 is performing the operations. We also have some disadvantage in serial schedule. What is that? The problem with serial schedules is that the limit concurrency by prohibiting interleaving of operations. If a transaction waits for an input-output operation to complete, we cannot switch the CPU processor to another transactions, thus wasting valuable CPU processing time. Okay, when we are doing a serial schedule, if the transaction is waiting for an input-output operation to complete, we cannot switch the CPU processor for some other transaction. So here CPU processing time is delayed. Additionally, if some transaction T is quite long, the other transaction must wait for transaction to complete all its operations before starting. So this is one problem in the serial schedule. So a schedule S of n transactions is serializable if it is equivalent to some serial schedule of the same n transactions. We say two schedules are called result equivalent if they produce the same final state of the database. Two schedules are said to be conflict equivalent if the order of any two conflicting operations is the same in both schedules S. Is conflict serializable if it is conflict equivalent to some serial schedule S. A serial schedule leads to inefficient utilization of CPU. Please remember, a serial schedule leads to inefficient utilization of CPU because of no interleaving of operations from different transactions. So next discuss about non-serial schedule. Schedules are said to be non-serial if each sequence interleaves operations from the participating transactions. You can consider this a non-serial schedule. We have an interruption in between in each transaction. First we are doing the read item. Okay, then there is a gap in between that. During that gap, transaction T2 is happening. Okay, once T2 is completed, switching back to T1, and we have some gap. After that, T2 is performing some operation. then simultaneously T1 is also doing. So this type of operation we call it as non-serial. Okay, so in each sequence of operation there is an interleave operations from the other transactions. We call it as non-serial. Next, we have serializable schedule. So what is serializable here? Serializable schedule gives the benefits of concurrent execution without giving up any correctness. Because practically it is very difficult to test for the serializability. Also it is impractical to execute the schedule and then test the result of serializability and cancel the effect of the schedule if it is not serializable. So practically it is not possible to test for one serializability. So then what is serializability? So serializability of a schedule means equivalence. Equivalence can be in the outcome, the database state, data values to a serial schedule, that is sequential with no transaction overlap in time with the same transactions. We call it as serializability. So please remember, serializable schedule means it gives the benefits of concurrent execution without giving up any correctness. So we have conflict serializable schedule. We'll discuss that. So what is conflict serializable schedule? When two schedules are said to be conflict equivalent if the order of any two conflicting operations is same in both the schedules. Okay, two operations in a schedule are said to conflict if they belong to different transactions. Access the same database item. Either it can be both write operations, or one is write, other one is read, or any one it can be done. So this is what we have studied, conflict. A schedule yes is said to be conflict serializable if it is conflict equivalent. Okay, if it is conflict equivalent to some serial schedule. What is conflict equivalent? If the order of any two conflicting operations is same in both the schedules, we call it as conflict equivalent. We can reorder the non-conflicting operations in S until we form the equivalent serial schedule S. We can perform two or more actions are said to be in conflict if it satisfies these three. What is that? The actions belong to different transactions. At least one of the actions is a write operation. The actions access the same object. It can be read or write. So when I say if it is conflict, these three things you have to remember. View serializable schedule. View serializability of a schedule means equivalence to a serial schedule with the same transactions. That means no overlapping transaction. We can say view serializability such that respective transactions in two schedules read and write the same data values. I repeat, view serializability means a schedule is defined by equivalence to a serial schedule, no overlapping transaction. And then we are doing some same transaction, respective transaction in two schedules read and write the same data values. That is, it is viewing the same data values. We call it as view serializability schedule. We have equivalence in view. What is view equivalence? A less restrictive definition of equivalence of schedules. View serializability, definition of serializability based on view equivalence. A schedule is view serializable if it is view equivalent to a serial schedule. Please remember the definitions of this. Next Next, we have transaction support in SQL. Transaction initiation is done implicitly when SQL statement is executed. Every transaction must have explicit end statement, either commit or rollback. Okay, for every transaction we have certain characteristics. So that is, one is access mode, diagnostic area size, the isolation level. What is access mode? Either we have only read or we have both read and write operations. Diagnostic area size. Option specifies an integer value n indicating the number of conditions that can be held simultaneously in the diagnostic area. The isolation level, option can be read committed, read uncommitted, repeatable read, serializable. We call it as isolation level. We have to categorize isolation level into read committed, read uncommitted, repeatable read, serializable. And we have to make sure that what type of violation it is done. We have studied about dirty read, non-repeatable read, all those things. We have to compare whether it violates any errors or not. So that's all about serializability. Thank you for watching and happy learning.